Hi, in this video, I will show you how to design this type of part in FreeCAD. And FreeCAD is a fully free CAD CAM system in which we can prepare our own 3D models, and FreeCAD can be used both as a hobby and commercially. Let's create a new project in the part design module, and we will start by creating a sketch. And we're going to create the sketch on the XZ plane because it's on this plane that I will create the main outline of this part, so that it pulls out in two directions symmetrically from the plane, so that later on we don't have to create an additional plane to create this part. And here, select Draw Polyline and draw the initial shape of this part. Here, we will use automatic constraints. Make sure that automatic constraints and automatic removal of redundant constraints are enabled. And notice that when I hovered over the point of the origin of the coordinate system with the cursor, it was highlighted in yellow. As I click on this point, the start of the polyline was constrained to this point. And now as I click here, as the x-axis was highlighted in yellow, the second point of the polyline was linked to the x-axis. And now draw more parts of this shape. And here, similarly, hover over the y-axis. As it is highlighted in yellow, then click so that this point is connected with the y-axis, and now hover over this point. When it's highlighted, then click. And now right-click to finish drawing the polyline, and right-click again to cancel this command. And now this line should be a horizontal line, so select this line and select Constrain horizontally. This line is vertical, so it's okay. And now select this line and select the equality constraint, and select this line and select the equality constraint. And now add the dimension of this line. Here, type 70. And notice that the dimension of this line has also changed, and now select this dimension and dimension this line. And here enter 10 millimeters. And thanks to the fact that we used the constraints and specified the appropriate relationships between the geometry's two dimensions were enough to dimension this drawing. Click Close to exit the sketch. Select Pad command. Here, select Symmetrical to the plane and enter 100 millimeters as the extrude length. Next, we will create the holes on this wall and start by creating the sketch. Here, I'll rotate the view so that it's in such an orientation that here we have the positive x-axis to the right and the positive y-axis up. And here we can create the circles. However, we will use the hole wizard, so these circles don't have to be precisely what the holes will be, because the holes will be created based on the data we specify in the hole wizard. However, here, let's add the diameter of these holes, equal to 10 millimeters. And right-click to cancel the dimensioning and select this circle and choose the equality constraint so that these circles are equal to each other. Then select these 2 points and the x-axis and select the symmetry constraint. Next, the vertical dimension to specify the distance between the centers of the holes. Enter 60 millimeters and select the horizontal dimension to specify the distance of the center of the hole from the outer edge of the solid. And here enter 50 millimeters. Click Close. And as I mentioned, based on this sketch, we will not directly create holes like this. Of course, we can do that, but here we will use the hole wizard, and these holes that we created will determine the positions of the holes that will be created using the hole wizard. And now select the hole wizard and note that by default holes were created with quite a different diameter than the one specified in the sketch. But here, let's select the ISO metric profile. Select the size of the hole as M10. This will not be a tapped hole, but simply a through hole for an M10 threaded screw. and here select countersink as the type. We can change the parameters here, but we can also leave it like this and click OK. Here I just wanted to show you how such holes can be created using the hole wizard. And this is how we will create this part of the solid. Now we will focus on this part of the solid. We're going to create a new sketch on the XZ plane. And thanks to the fact that we just created the main sketch on the XZ plane, we can also use this plane to create this solid fragment. And here, at first, we will use the external geometry. Here this edge is a little invisible because it is in the middle of the solid. But if we turn on the section view, it will already be clearly visible. And now select Draw a Polyline and hover over this line so that the beginning of the newly drawn line is connected to the reference line on the model, and draw the initial shape. Here, as in this case, we will constrain the next point of this line to this line. That is, when this line is highlighted in yellow, then click to constrain the point of this line to this line, and the drawing of the polyline is still active, and finish the drawing at this point, and right-click to finish. Again, right-click to cancel the command to draw the polyline. And now let's add the dimensions. At the beginning, the vertical dimension, and select this point and here enter 10 millimeters. And do the same thing here. Then let's add a rounding. Let's add the dimension of this radius at 15 millimeters. Then, let's select the angle dimension, and let's add the 60 degrees angle dimension here. Right-click to cancel the dimensioning. And here, as you can see, we can still change the position of this sketch. And here let's add such a constraint, which will determine that the center of this arc will lie at an equal distance on the y-axis between these points. That is, as if the center of this arc will lie on a line, passing through the center of this line, but we don't have to create a line for this. We can create a point. Let's create a point on this line. Then right-click to cancel the drawing of the point. And now select this point, and select the symmetry constraint to specify that this point lies between these 2 points, that is, in the middle of this line. And now select this point, and select the horizontal constraint to specify that these 2 points lie on one horizontal line. Here, change the dimension of this radius to 10 millimeters. And we will create a circle whose center will coincide with the center of this arc. That is, hover the cursor over this point and click here, and draw a circle and add the diameter of the circle. And here, as the diameter of this circle, enter 10 millimeters, and OK. Exit the sketch and add an extrusion. Symmetrically from the plane and the length of the extrusion, 10 millimeters. Click OK. And now create this part of the solid. That is, create a new sketch again. Select the XZ plane. And now use the reference geometry and click on this arc. Then click on the circle, and right-click to cancel this command. Switch to the section view and select Draw a Circle and draw one circle, the center of which will be at the center of this circle. And here to define the second point, if you hover over the reference line point, the circle is immediately related to this point, and the diameter of this circle is the same as the diameter of this arc. And now we're going to create a second circle, and here I also want the center of the second circle to coincide with this point. So click on this point, and I would like the diameter of this second circle to be the same as the diameter of this reference circle. Therefore, when this circle is highlighted in yellow, then click at this point. But if it wouldn't work, and you wouldn't be able to link it that way, we can do it manually. Simply select this circle and that circle and select Equality Constraint. And, okay, the sketch is finished. Click Close. And now we add an extrusion. As in the previous cases, in two directions, and here the length of the extrusion, 80 millimeters, and this length of the extrusion is not the length of the extrusion in one direction. The overall dimension of the part that is created with this operation will be 80 millimeters. That is, we have 40 millimeters one way and 40 millimeters the other way. Click OK, and now we will add chamfers and rounding. And to make it easier, switch to wireframe view and select, with Ctrl key, these edges. Select the chamfer operation and add a chamfer with a dimension of 1 millimeter. Then select, with the Ctrl key, these edges of the solid and choose chamfer. And here, a chamfer size, 5 millimeters. And select, with the Ctrl key, these edges. And here select fillet, and let's also type 5 millimeters. Switch to the as-is view, and we have a solid created. As you can see, thanks to the fact that we chose the correct sketch plane at the beginning to create the base sketch, we avoided the need to create additional planes to create other parts of this solid. And the modeling of such a part itself turned out to be easy. And that's all for today. Thanks for watching, and please subscribe to this channel.